Okay, so recording has started. Recording has started. So the question that I'm going to use to for our pseudocode is something that, well, some of us might have met it before, others might not have met it before. We're going to do an exercise on identifying a triangle and stating what type of triangle, that triangle that that shape that we've identified, that is a triangle. We identify what type of triangle it is. Okay, so not screen, sorry. I'm gonna have to start sharing the screen after a while. Window. So here is the question. The question is that we want to write an algorithm that allows a user to enter three values that will form the sides of a triangle. Okay, so we have a user entering three values that will form the sides of a triangle. If a triangle can be formed, then the program will state what type of triangle it is. Otherwise, it will state that a triangle cannot be formed. And this is the question that will base this. This is the first, after we learn the basics of the in and outs of the C compiling. We want to then attempt this as our first real program. Okay. So we starting at like a decent level, a mid level. We ain't starting with no, we do one or two little baby programs just to show just to get a general idea of how programming is structured, and then this is what we have to do before the end of class. I also wanted to ask, it was last week that I gave you all the question about whether or not the numbers could be read the same way forward and backwards, not so? Yes?
Yes, sir. Yes.
All right.
Yes.
Just indicating, we're not going into that right now, but indicate, anybody feel like they figured it out? Anybody got it? Anybody spend time on it? After,
Yes, Google it, sir.
you Googled it?
Yes, was wondering.
Oh. Oh no.
Honestly, I reached a step where, like, while watching it, and I realized that it had something to do with the powers, with like that like what, like 10 to the 1 would be kind of equal to 10 to the whatever. And after that, I realized why it's trying to give me gray hair, and I just stopped. Yeah.
Well, I could tell you for sure that we're gonna have a whole lot more gray hair problems coming our way. So, we had to stick at it. Okay? And don't be afraid to collaborate, people. To bounce ideas off each other, see what one person have, another person have. Everybody has to contribute towards getting everybody else to the answer. Okay? If you try to go through this yourself, I mean, a lot of the times it's only going to end in pain and frustration. And, it's much easier to go through pain and frustration as a group. Right? So at least group pain and frustration is easier than personal pain and frustration. So don't be afraid. Make a friend. Look at the names in class and be like, hey, let me message this person and see. If somebody messages you, don't duck them or avoid them or something. So try and work with them. Okay? If you don't know the person, if you know the person. So I'm telling you all, even if you all don't know each other, if you all, you could just pick a name at random from class and be like, you could pick 3 names and say, let me see what these 3 people have and if anybody is willing to work with me. And I could share what I have, and that person could share what they have. Okay? And be honest, if you all at different places, it's about working together so that both of you get better. All right, folks? We could agree on that as a class.
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
All right. Good, 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 good. Okay, so I hope all the people whose voices I didn't hear were there shaking their heads yes in front of their computer, or just saying yes to their muted microphone. Okay, so we want to write this algorithm. It will allow a user to enter 3 values. What do we need to know for this algorithm? What do we need to know for this algorithm? We need to know how a triangle can be formed. And then, depending on if a triangle can be formed, we need to know what are the properties of a triangle that will dictate what type of triangle it is. Okay? So this question has 2 parts really. 2 big questions. Okay, so we could sketch a quick little chart. Can a triangle be made? And if the answer is yes, then we ask what type of triangle. And if the answer is no, well, then we say no triangle form. And if we could say what type of triangle, what are the types of triangles we have? We have, right?
Scalene, equilateral, and isosceles.
Right. So we have scalene, equilateral, and isosceles. And scalene is where all 3 of the sides are different. Equilateral is where 2 of the sides are the same and 1 side is a different value. And isosceles, sorry, equilateral, yes, sorry, that's isosceles. Equilateral is where all 3 sides are of the same value. Sorry about that. Okay? So thank you for paying attention, because it looked like I wasn't paying attention to myself just now. All right? I was just talking. All right, so we know that scalene is where, isosceles, scalene is where all 3 sides are different. Equilateral, all 3 sides are the same. And isosceles is where we have 2 sides that are of equal value. How can we represent this? So now that we kind of have a rough sketch, let's answer the question, how do we know if a triangle could be made? We know if a triangle could be made if any one side, right? Well, let's go on the no side. If any one side is greater than or equal to the sum of the other sides.
No, so you have it backwards as if two sides must be greater than the other one.
What's that?
You have it backwards is that 2 sides must be greater than the remaining side.
Right, so if any one side is greater or equal to the sum of the other 2 sides, then no triangle could be formed. So that's the reverse logic of what you said.
Oh yeah, I didn't realize it had that thing at the bottom there.
Right. So we can put what you say on this side though. Right? So the sum of the two sides must be greater than any other side, right? The other one side. So this is the logic that we'll be working with here. And you notice this don't look too much like a flow chart, but we have a way to express our logic. So even as a note, don't write this for exam though. Right? Don't write this for exam. This is not a flow chart. But this is us working on our own logic, but this is easy to convert to a flow chart. Not so, Clement?
Yes, yeah, of course.
Right. Because it's pretty much a flow chart, but it's our own flow chart notation. If we were to put it in a standard flow chart notation, then we would have to use the diamonds and the arrows, you know, and the boxes and the parallelograms, etc. Okay? But I'm going to skip that for now, developing that flow chart, and I'm going to jump to doing the pseudocode for this. So let's try and see if we can work on the pseudocode for this based upon what we just agreed on. Everybody's fine with that? Is anybody lost at this point? Right? Good. Okay. So at least I have nobody sitting in my class at this point and wondering, well, how come we ain't doing no performances because you sign up for performing arts and we only talking about programming or something. So right. Okay. So everybody here, everybody's with us. So we know that we need three things. The program says the algorithm needs to allow us to enter three values. And I'm going to call some names to help me along today. Right? Alexandra.
Yes, sir.
Right, Alexandra, you're with me. I want to name these three values. What would be three appropriate names to give for these three values of my triangles? What you would call them?
So, well, either side A, side B, and side C, or side 1, side 2, or side 3.
Okay, so we could go with that. And what data type would they be?
So, integer.
Okay, so we're working with integers, and we can say side A, side B, and side C. Correct? So the next thing that we'd want to do, Alexandra, is to ask the user what? Narrate, just say out what you think should happen at this point. We declare the variables, what's next?
Print.
Okay, so we say print.
And then in quotation marks, you would put enter three values.
Okay. And the next statement?
Input.
Mm-hmm.
And then side A, comma, side B, comma, side C.
Very good. Thank you very much, Alexandra. So now that we have side A, side B, and side C, Kyra, now that we have side A, side B, and side C, what is the next thing that I want to do? I've collected the data that I think that I need for my algorithm. Kyra, so where are we going from here? What needs to happen?
Well, you had to figure out, well, you had to do the condition, like if any one side is more than or equal to the sum of the other sides.
Right.
You have to find that out.
So you could tell me what I need to type to know what I need to put there?
Well, you could start with side A. So if it's a condition, if
So we start with the word if.
so, if side A is more than or equal to, would it be just side B plus side C?
Right, yeah, this is correct. Side B plus side C.
Side C. Then
So we check to see one side, right? So let's kind of draw it out. We have side A, and this is side B and side C. In this instance, we got side A to be 11, side B to be 10, sorry, not 10, side B to be 5, and side C to be 4, right? So this is A, B, and C. What do we notice here? Can this form a triangle?
yeah. Wait.
Yeah?
I mean, if you bend it a little bit, yeah. But no,
So
not in
you
the
want
same
to form a triangle that looks like we're not bending those sides of this triangle, right? So we see that if we have a line that is 11 long, and then we have a line that is 5 long, and we have a line that is 4 long, we would never get this to touch. So we can't form a triangle in this instance. But the thing is, we have to check it from all 3 sides. What if in this case we have this statement that you have here, and side A was the 5, so this is A, side B was the 11, and side C was the 4, right? So side C was the 4. Does this here check in this case?
It wouldn't, no.
Right? So the thing is, look at what's going to happen in this. If we check it for this, what we have written here for this case. When side A is 11 and side B is 5 and side C is 4, you get is 11 greater than or equal to 9. And this is true. Right? So in this case, it tells us we can't form a triangle. But what if we check in it for this second case here? For this second case here, we have if 5 is greater than or equal 11 plus 4, which is false. So we have to write our own case for this side. Understood?
Yes, sir.
Right. So we have to go on and continue this now. We have to continue this. So we say if side A is greater than or equal to side B plus side C, or if side, in this case, like C, if side B is greater than or equal to side A plus side C, or side C is greater than or equal to side A plus side B. So we have to check in this instance each case, and there might have been an easier way to write this here, but might or mightn't. But don't think about it too much, because this is a small scenario. So we had where C could be the 11 side, A could have been the 4, and B could have been the 5. And in all 3 of these instances, we can't form a triangle. But what would happen here is that in the event of, in the case of let's say, for instance, just this first triangle here, we would have gotten true for this, we would have gotten false for this, and we would have gotten false for this. But true or false would be what? Would give us
It will give us true.
It will give us true overall. Because once one case is true, it doesn't matter if the other cases are false. This is the case that dictates that a triangle cannot be formed. Understood? When you're checking from side B perspective, yeah, right? Sorry, in this instance here, if we're using the same first scenario, the statement holds true, when you add A and C, B is less than it, right? So it seems like it should be able to form a triangle. And in the case of side C, in this instance, it seems like it should be able to form a triangle. But in the case of side A, it tells us that we cannot form a triangle. So all of them have to be false for us to try a triangle, to form a triangle. Which means that if any one is true, then it means that a triangle cannot be formed. So we have to say here, if side A is greater than or equal to side B plus side C, or side B is greater than or equal to side A plus side C, or side C is greater than or equal to side A plus side B, then we can say with full confidence that a triangle, you have to put it in a print statement. What are you doing, Mr. Valdez? A triangle cannot be formed. Are you all with me? So we've now ruled out the instance where a triangle cannot be formed. So inside of the else, we can now go on to now working out what type of triangle can be formed. Are you with me, Jonathan?
Yes, sir.
Good. So how do I figure out from this point what type of triangle could be formed? We have three cases for triangles, right, Jonathan? We have one where all sides are equal, one where all sides are not equal, and one where two sides are equal. So we could write some code, and the code for checking to see if all sides are equal is easy to write. The code for checking to see if all sides are not equal is easy to write. What about the code for if only two sides are equal? Well, if all sides are not equal, or all sides are equal, then the only other case is two sides are equal. So we don't have to write the code for that. We could put that in an else. So we have to put this in an if, and anybody wants to walk me through?
So yeah, I could walk you through, sir.
All right, Clement.
So you could say if side A is equal, side B.
Side A is equal to side B.
And side A equal side C.
Mm-hmm. Yeah. Then what?
Then you could close the brackets, sir. Right. And you could say print this is a equilateral triangle.
So will not be isosceles?
No, this is equilateral.
Hey.
Right? Because if it is, one side A, let's work it out. If side A, so this is A, this is B, and this is C. right? And we have 5 here. If is it equal to side B? Yeah, once A and B match. So once A and B is true, and we can check A against C, and this is true, there's no need to check B against C. Because if A and C would have matched, then A and B would have matched. Understood? But in any case where any one is off, then you would get, of course, a false somewhere or false in both instances.
So you
All right?
need to put like the answer. You can't just put side A equal side B equal side C.
No, you have to put the and because you need granular statements that will equate to this logical output. Right? Yeah. All right. So what's next, Mr. Clement?
Right. So now you could say else if. Is an else if statement here.
If. Mm-hmm.
Then you could say if, well, side A is equal to side B.
You're going for the isosceles?
Yeah, well, you could put this in brackets here, what I'm saying, sir. So,
Okay.
open.
Well, why not go for the equilateral? Because the isosceles is long. And we want to be lazy.
Okay. Well, if side A is not equal to side B.
And
side A is not equal, well, yeah, it's not equal to side C. And then you could print.
No, this one you have to go on with the further and. And side.
All right, yeah,
B
right. And side B is not equal.
Not equal. So this one you have to take the extra step. Because if it is, we had an isosceles in this case. If we left it at this first one, we could have had 6, 5, 5, where this was A, this was B, and this was C. And what you would have gotten here is that side A isn't equal to side B, this is true. Side A isn't equal to side C, this is true. So you see, if you left out this part here, if you left out that part there, you would have gotten true as the isosceles. When it's not true, it's actually equilateral. But in this instance, now putting side B isn't equal to side C. This is false. And we have true and false, which will give us true and true is true, but true and false is false. So in this case, it's not a scalene triangle. It would go on to say that it's an isosceles. Okay, and we could work out the code for the isosceles, but we'll see how long it comes up being, right? So, and this is why sometimes you think it through and you say, well, which is easier to code? But we'll take a look at it. So we say print. This is ISOCELES, an isosceles triangle. And then in this case, the last case, we'll just have an else. Else print. This is a. Oh, sorry. Why you all make me write isosceles there?
I was waiting for this type and then I was going to tell you.
Right. This is an isosceles triangle. Okay, I'll forgive me. I'm tired. End it, right?
You triangle wrong as well.
Triangle. Nice. All right. So the spelling errors, I don't mind. I like to call out the spelling errors whenever I see it because I am terrible at spelling, especially while I'm talking at the same time. So if it is that you see a spelling error, call it out, fix it one time. So this here is going to give us, a program or an algorithm that we could enter 3 values into. And so let's test it with some values. Let me ask somebody to give me some values to test. Jarrell.
See, I think somebody was trying to ask a question.
Yeah.
I'm not sure.
Oh, sorry, Jarrell. Before we go on to you, anybody have a question?
So I'm just gonna let you know you spell isosceles wrong.
Yes, sir. I'm not going to answer that.
Yes, spell it for me.
It have a S after the O.
S. I spell the whole thing. Spell the whole thing.
ISOSCELES.
That's how you spell isosceles? Well, I've been spelling it wrong my whole life. All right.
See, well, it's a
All
good
right.
thing, you know, teacher say.
Huh?
See, I say it's a good thing, you know, English teacher.
No. Right, but my mother is though, but she might be hanging her head. Right, my mother spent her whole life as an English teacher. Okay, the other rules of English I could work with, but you see spelling, sometimes spelling is, it just goes. All right. My maths teacher must be disappointed as well. Oh well. Right, so we have isosceles. Let's just enter values inside here. Let me ask Jarrell. Give me 3 values and let's go through. Yeah, any 3 values.
9 and 12.
What 9 and 12?
7, 9 and 12.
7, 9, and 12. So we have side A as 7, side B as 9, and side C as 12. So let's work out this first section here. If side A is greater than or equal to side B plus side C, is side A greater than 9 plus 12? Is 7 bigger than 9 plus 12? Gerald, that's to you, eh?
False.
That's false. Or is 9 greater than or equal to 7 plus 12?
False.
Or is 12 greater than or equal to 7 plus 9?
False.
False. So we cannot go into this if statement. We have to jump to the else. Because we got false or false or false, and that is the case where false would have been returned, and we need to get true for the expression to go into the if statement. So we then go into the else, and then we say, okay, else is side A equal to side B? Is it equal to side B? No, this is false. Is side A equal to side C?
False.
Also false, yeah. So it's not an equilateral. Is side A unequal to side B?
Yeah, false.
False?
No, true.
Oh, true, right. So this is true. Is side A unequal to side C?
True.
This is also true. 7 is not the same as 12. So this statement is true. And is side B unequal to side C? Is side B unequal to side C? This is also true. So at this point this is a scalene triangle. Okay? And because we went into this one, we can't go into this one. We jump to the end if. We jump to the end if, and we'll continue the program as necessary. Yes, Kyra?
Sir, you have 2 more typos up there, sir.
You want to point them out?
So, an scalene and a isosceles.
Right. Yeah. That's because I initially had isosceles in that section there, right? So thanks very much. Okay. All right. Any other issues or typos or anything?
Yes, sir, you had the wrong variable name for side C in the input statement.
In
the input statement, you had the wrong variable name for side C. Supposed to be a commoners.
Right. Thank you very much. And that's something like that. While it needs to be consistent, it's good to point out, like a little error like that. When you write your algorithms for exams, it's unlikely that you'll be penalized for something like that because it's understood that it's going to be a typo. But if it is like we see when correcting that you have inconsistencies all the way through, then you might lose a mark there. But if it happens like once, it's not going to be like they're going to give you wrong or something. So, all right. So everybody good with this? Yes. It's easier to test it without having to draw your trace table and copy the values and check it and stuff like that. Even though you have to do this for exams, but a good way to strengthen it is to actually practice by programming on the computer itself. So let's then we're going to jump to doing some actual C programming on the computer system. Okay, so just give me two minutes and then we will start on C. So you can get a little water. It's 9:22. We'll take a little 3-minute pause. Okay. So I had a little glass of water, and I think that we can resume now. So we want to start up our code blocks, and I assume by this point everybody got it installed. There should be a little issue. Okay. All right. So we want to start up code blocks, and I'm going to share my screen. And your code block should look something like this. Yes, everybody seeing my code blocks up, right?
Yes, I see that.
Good. So in order for what we will be doing, we'll be writing just little standalone C programs. And what I would suggest that you do, first things first, is to start file, new, empty file. And we'll have this editor window opening up. Just gonna make it a little larger, right? First thing is to save. And what I suggest you do is to save your what you call it? The file to a folder on the C drive of your computer or any drive, actually anywhere that you could locate it, but I prefer to put it on the C drive. I'll put it in my cloud storage for now. And I'm going to create a folder called Valdez _1, 2. Okay. So I'm going to why I'm recommending this folder is so that we can have a place to keep all of our C files that we will be writing in class. Because between now and the end of January, we're going to write a lot of C files. Okay. So once you're inside of that folder where you're going to store your code, you're naming the file first, or let's name it hello.c. And all of our files need to be named .c, and none of our files should have spaces in the name. If you have spaces in the name, you're going to get problems with compiling because it might not update the object files properly. Okay, so you don't put spaces in the name of the file. Okay, so we have file name hello.c. We press save, and then we start to type. And the first thing, this is how all of our C files will be formatted. We have to include stdio.h, and we have to include stdlib.h. These are some files that are like library files that contain common functions that are used throughout the execution of our code. So include stdio.h, and we'll say this here contains commonly used like input-output files. And this one here contains commonly used general library files. So this first one here is the standard input-output library. This is where your functions for printing and reading input from the user are stored. That's where they are stored. And this stdlib.h library is where we use some other common functions. Like we'll see something called getchar. That's used inside of there that just cleans up input from the user. Everybody's with me so far? Yeah? No?
Sure. I
Yes.
didn't get it. The part where you open a new file and then say new template. Where you click in, sir?
No, you're clicking straight up new empty file.
New. Oh, an empty project.
Yeah, empty file.
All right.
Yeah. These things that I'm writing at the end of my code, they're called comments. So this is a single line comment. And this here This is a multi-line comment. It allows me to write comments across many lines. Anything inside of the comment tags will be ignored by the compiler. So this is your compiler here, and that's what we use to write code. So everybody cool with comments, and all we have is some libraries here. All of our programs that we will write will have a main function. And this is the main function here. Int main, open and close brackets, and open and close curly brackets. Okay? The main function is where our code always starts executing from. This here is curly brackets tell us what is under the control of a statement function. So we have curly brackets, and the curly brackets allow us to say what is under the control of a particular statement or function. Okay, so we have int main. We have int main, and the main function, that's where our code starts. We have to have a curly bracket to start executing to show everything after this curly bracket is where main control is. And this end curly bracket here, everything before this curly bracket is where main control ends. Everybody good with us so far?
So I have a question. The open and close brackets after the main. What was that about exactly?
Those, because main is a function, and we will learn the purpose of functions later. Functions could take arguments. So if it is, there may be some instances where one program might pass a value to another program, right? If that happens, then we could put something inside there to receive that value. We won't be using that. Not for the main function, but we will be using it for other functions that we write later on. So what I'm going to say, it's one of those things that you don't worry about it now. Just do it because you have to do it. And later when we have to put it in context, it will all become clear. The same thing is true for this return statement. Return 0. Forget about this return statement. This return statement just matches with this int statement up here. Your program will work without it, but it's better to have it because you have int main here. Some programming implementations allow you to put void main and put the return 0. CodeBlocks does not allow that. So it's just good code, right? So we will learn more about the return statement later. All right, so this is the structure of our, essentially this is the structure of our C programs. So everything, ignore all of the comments. We haven't written much so far, right? We haven't written much so far. So int main is where our program will start. We must have that curly bracket to start and close. And if we just wanted to print a message to the user, I could say print F. I know some of you all might have been noticing that I've typed printf multiple times before in my pseudocode, or I've written it on the board. This is where the habit comes from. Printf, and I could put inside of some quotes, so class of 2023, right? Welcome to C Programming. So hello class of 2023, welcome to C Programming. And this is where we can then go up to the top. These three icons here are pretty important. We have build, we have run, and we have build and run. Build allows us to compile our code into an executable on the computer, which will then run. Run runs the last build made. If you don't have any build, like in this case, if you click it, it'll say the file has not been built yet. Do you want to build it now? If I click yes, it will compile it and then run it. So yes, and this is what I get. This is my program. Is this what I wrote? Yes, this is what I wrote. So this is my running program. Jan?
Oh, sorry, I don't know my mic was unmuted. I just jumped and we had to Apple watching this.
Thank you. Any questions so far? Did anybody typed it up, got it working?
Yes, sir.
Mm-hmm.
So it have to be printf, like the print Z or something.
So it's printf. Printf is the name of the function, and it stands for print function. Stands for print function.
So I have a question, sir. You know how
Yes.
like f is a function, right, sir?
What
Could
is
I
a
like
function?
printf, sir?
Mm-hmm.
Right. Could I like make my own printf function maybe, and make it like do the same thing and rename it something else and stuff like that?
Yeah, you could.
Because I know.
When we get to functions, you could do that.
For real, sir? Are you looking forward to
Yeah.
that then?
I mean, I don't really think it's a. By the time we get to functions, you'll be so ingrained in terms of using printf. But you could write your own functions, like you could write your own header file like library here. So that before your program compiles, it pre-processes it and loads up all the functions that you write. If you have your own special needs in terms of executing programs. But we don't do that as a we really more focus on getting to be able to manipulate the language and solving problems than doing things at those levels. But by the time we finish doing what we have to do, if you want to go into doing stuff like that, it's very possible to do it. And it's not going to be too difficult for you to do it.
Excuse me.
Yes.
What up in green on top where you're saying include? That have to put it up on all the programs, right?
Yes.
Okay.
Right. So those
include to everything.
The include as as it is there. Because in time we're going to use some more built-in functions like built-in header files like string.h and time.h and stuff like that.
So just do me a favor, right? When class finish or whatever, you just copy this and send this in a Word document to me now, please.
Yeah, all the files will be available to you. I wouldn't suggest a Word document, because sometimes sometimes the formatting is severely impacted via a Word document.
So it's not really the format I want, is actually the words now.
Okay, yeah, no problem. I upload the code after every class.
All right, cool.
Yeah. Any other questions? No, so we can go on to our second program. Yes? And our second program could just be a simple input program simple input program where we want to input 3 values and say which is the biggest number. Okay, so let's do that. So again, we do our include stdio.h, our include stdlib.h, and you notice that nothing highlights until we save it as a .c file, right? We have to save this, and this we could call this second.c. And as soon as we say second.c, it then formats in the coloring that allows us to, highlight it and reserve the words, etc. So let's write a C program that accepts 3 values from the user and outputs the largest value. Right? At this point, we want to assume that 3 distinct numbers will be entered. Okay. So in this instance here, we have we now have where we have to have input and we have to have output. We have input and we have output. Okay. So we want to write a C program that accepts 3 values from the users and outputs the largest value. We're going to need 3 variables. So we can say int a, comma, b, comma, c. Right? The variable names at this point, they don't have to be too creative because this is all about just learning how to use variables. So 3 variables, a, b, and c. The first thing that we would want to do is we would want to prompt the user. So we would say printf, please enter a number. And I put this space here. So that the value is not going to be jammed up against the semicolon, sorry, the colon. Okay? Notice that I have a semicolon after almost each statement, as well as I said the word semicolon. That semicolon ensures that the compiler knows where a statement finishes. Okay? So we'll be using that semicolon a lot when it comes to programming. So we say, please enter a number, and I say, how do I enter a number? So I prompt the user for a number here. And to enter a value inside of C programming, I do this. Scanf, and because the value is a integer value, I use the placeholder %d. And to identify where in memory the variable A is stored, I have to put an ampersand before A. The ampersand is the and sign. So there's a lot going on in this statement. The scanf statement, scanf tells me to read in an integer, which is %d, and store it in the variable A. I want to do this 2 more times for B and C. right? So then I'll do it for B, I'll do it for C. Okay, so I prompt the user for the value, for a value 3 times, and then I scanf 3 times. But I also have something that I like to do after I scanf to clean my input up so that I don't get, weird, so that I don't get weird input errors. After I scanf each time, I use getChar. And getChar in this instance, getChar has multiple uses, but getChar is used here. getChar is used here to clean up the scanf input. And I have to do this after each scanf. And yes, there are easier ways. I could have put them all on one line. I could have put them all on one line, but I just want to do this for emphasis right now. So we have please enter a number, scanf %sign D, store it in A. Please enter a number, scanf %sign D, enter it in B. Please enter a number, scanf %sign D, enter it in C. How do I get the largest value printed out from these? Sorry, from these 3 values? I have to use an if statement. I will have to use an if statement. So I go here and I say, if, and the if statement is very similar to the, to how we do it in pseudocode, right? If A is greater than B. Now, I'm doing it here a little different from how we'll do it normally, right? Because for the next example, where we write in the code that we wrote for pseudocode in class, then I'll use the ands and ors. Okay? If A is greater than B, what do I want to do? Right? If A is greater than C, this is some terrible code I'm writing here. What do I want to do? I want to printf A is largest. Okay? A is largest. Else if what? Else if, well, we just established if A is greater than C, then A is largest. Which means that else if A was not smaller than B, or if A is not smaller than C, right? If B is smaller than, you know what? I'll just use the ands at this point because I don't want to. If A is greater than B, and I'll show it in this algorithm. So for the AND statement, we use AND in C code is represented by ampersand, ampersand. Or in C code is represented by type pi. So we have and or. So if A is greater than B and A is greater than C, then what does this mean? It means that we could printf A is biggest. %sign D is the biggest number. And what number was that? That was A. Else if B is bigger than E and B is larger than C, okay, then what do? It means that we want to print out that B is the biggest number, else C is the biggest number.
Say,
Mm-hmm.
instead of doing all this, say, I think you could just store the biggest number in one variable, and then you just have one print statement at the ending of it.
You could, right? So you could have a separate variable called biggest, and you say biggest is equal to A, or biggest is equal to B, or biggest is equal to C, and then you just print out biggest at the end. Right? So that's our alternative way to do it. I left out my semicolons from the get char. Yeah.
So in the scan statement, why you saying %D if you never declare D as a variable?
No, this is a placeholder that tells me that an integer is expected to be read here.
So where did D come from, sir?
Decimal, I guess, base 10 denary. Right? If it was a floating point, it would be %F. If it was a character, it'll be %C. Yeah. If it was a string, it will be %S.
S. All right.
Okay. So %D. I think you could also use %I for integer, but I'm not 100%. I just gotten so used to using %C that let's see. Right.
Say, while looking for that, say, you could re-explain what the get char is up. Say, ask if you could re-explain what the get char function is again.
Right. The get char is used to clean up a scanf input. So sometimes, and I'm gonna put a get char here. Right. Look at it here, and then I'm gonna put a printf and just print a asterisk here, and then I'm going to remove the get chars, and you'll see the difference in behavior. So I'm running this program. Please enter number 432. 4 is the biggest number. You notice that the get char after 4 is the biggest number. There's a pause here, and I have to press enter before I could see that asterisk print out. Okay? Before I see that asterisk print out. Now, if I remove the get chars from here, right, even though I still have this get char down here, please enter number 543. You see it just straight up jumped to the end of my execution. That is because after I pressed enter for 5, 4, and 3, the buffer, the input buffer, it still held kind of like the confirmation entry there. So what a get char does after a scanf is that it clears the buffer of that confirmation entry, even though it saves the value, so that your program doesn't jump ahead of where it needs to be. So that this get char at the bottom here actually acts as kind of like a pause and wait for input. It's very subtle, but it could frustrate you when you start the program if you leave it out of having it after the scanfs.
So it could be like any character. It doesn't necessarily need to be enter.
Huh?
So
No. All right. So when you enter a value, right? The enter key. The enter is actually made up of something called like a carriage return. Okay. So what you get with the enters is you get, and we'll get into those invisible characters. You get a \n \r. What the scanf does is that it reads the \r, but sometimes the \n might still exist or it might read the \n and the \r might still exist. What the getchar does is it cleans up all of the input after an enter entry, so that the next input doesn't queue up like an additional enter into the system. It's something that you'll notice with practice. Trust me, right? Just trust me. This is one of those things that you do kind of have to trust me on. And you might write a program and notice that it's behaving erratically, and then you'll put your getchars after the scanf and notice that it's behaving as you intended. Okay? So the getchar essentially clears the input stream buffer, what is called the input stream buffer of the computer system for your program. So that when you enter a subsequent value, it is the value that you want and only the value that you want. And there's no extra carriage returns or new line characters inside up there. You see, I'm trying to explain it to you, but I don't think that we have like a full reference. So, and that's, I do stress this with students. There are certain things that you're just going to have to trust me on until you know a little more and you could put it into perspective. Okay? I think I've asked that before.
So you could scroll down a little bit so I could see the if statement.
Yeah, no problem. So let me know when we get this working.
So how come it is we printing B again in line 28?
Huh?
How come it is we printing B?
Oh,
at
because
line 28?
I didn't change it to C.
All right. Okay.
So
Yes, sir.
so that last the printf, and then you have the quotation marks, the asterisks inside. What's that for?
Oh, yeah. No, that was just for the getchar example.
Oh,
Yeah, we can remove that. Everybody has it working?
Yes, sir.
Okay. So let's take a 10-minute break. We come back at 10:10, and then we'll do the we will do the code for the what you call it? Help me out here. We'll do the code for the question that we did earlier in class with the triangles. So it's in the code is in the class chat. Okay, so the recording has resumed, and we want to work with the last
So I don't know if it's just me, but your audio really bad. We're not hearing you.
Yes, you sound like a transformer.
Yes,
Any better?
Yes, sir.
Much better.
Yes, sir.
Yes, it fixed now.
I don't know what happened there. Let me
So it gonna right back again.
So it's not it's not fixed.
sorry. Better.
so you got exposed, so we know who you are.
Oh my gosh.
I feel to say just wanted to watch,
no. I have no idea what happened there. I think the Bluetooth is messed up for a bit. So and I am not. It's not that I'm a part of evil robot overlords that looking to take over the country by teaching people how to code. But I don't even know why I would say that unprovoked. We want to write the one for the triangles. So we have triangles.c. Okay, I'm going to put inside of some comments the pseudocode here, just to guide us. Okay, this is what we did earlier, and we wanted to express this as program code. So, regardless of whatever I put here, unless it's like name information and all of that, I like to see my include statements up on this std mode.h and include stdlib.h. And then I'll have my int main, open and close bracket, and put my return 0 statement here. So we want to express this. We know that we have 3 sides of the triangle. So we have, anybody went ahead and attempted it in C before I start? Yes? And
yes.
You got it working?
No, sir.
No.
All right. What were the issues that you encountered?
So well, I get the point where I reaching to enter the sides, the value for the sides, and as I enter the first side, it just saying it have a problem and your program stop working.
You sure you didn't forget to put the ampersand in this kind of statement?
So the Yeah, I put everything there. So it just giving me it running at first, you know, and it letting me enter the first number. But as I press enter to continue the code, it just shutting it down and it's stopping it for itself.
Okay, so I'll take a look at that after we type up this. Clement, where's your problem?
Yes, it might thing not even running, say. It have a problem with the first if statement to check to see if it could actually be made into a triangle. I think it's something with the logics or something. Yeah.
Okay, all right. Well, let's see if what we do clears up your issues, and if not, then I'll ask you to show your screen and we'll debug. So the first thing that we want to do is we want to declare our variables. So we have 3 integers, int, right? SA, SB, and SC. So side A, side B, and side C. Then we want to ask the user to enter the 3 variables. So we say printf enter 3 numbers, or please enter the 3 sides separated by commas. So before we only entered 1 per line. Let's take a look at how we'll enter multiple values per line. I could go scanf. I could put %d, comma, %d, comma, %d. Now what this means is that my values, my integer values must be separated by commas with no spaces. Okay? I want to store the first value into side A, so I have to put ampersand SB, and I put ampersand SC. And what I like to do is I like to compile my code while I write. So I write a line and I compile, and I look down here and I see build finish, 0 errors, 0 warnings. That's a good thing. Okay? Don't write 20 lines and then compile, because you might have an error inside of there and you now have to go through 20 lines. If it is that you write 3 lines and check, or a couple statements and check, there are instances where you're going to have to write more, of course, because sometimes you have to put a logic. But try and keep it measured, so that if it is 2 lines ago that I knew that everything was working and I add 2 lines, then what does that mean? That means that the problem probably exists in the 2 lines that I just added. Not always, eh? Your logic from before could also play a factor. But chances are, at the very least, I know what I did before I checked, so I can go back and remove those 2 lines, or check line by line and see if there's any sort of issue. So it's write and check, write and check, write and check. Okay? After the scanf, we normally put a catcher. And now we want to move forward. So essentially, we're up to here. So we want to put an if statement, and we say if what? If SE is greater than or equal to SB plus SC. And that's what we, sorry, not and, but we had or, so I have to use the pipes. Or SB, side B, is greater than or equal to side A plus side C, or side C is on side B plus side A. What does this for us. It means that a triangle cannot be formed. I could put that there, printf. A triangle cannot be formed. And what I can do here is I can put an else, and then inside of the else, I could just simply put a triangle can be formed. And then check that at this point. Okay? I can check it at this point and make sure that everything is okay. Everything looks okay so far. Let me run it. 3 sides separated by commas, 11, 5, and 4. A triangle cannot be formed. I will run it again.
So, I would see you would have a mistake because if what you have side C is greater than, you don't have equal to.
Okay. Yes, thank you. So I left out the greater than or equal to. Enter the 3 sides separated by commas. Right? 3, 4, 5, a triangle. Oh, I copied the word cannot as well. So a triangle can be formed. So if I enter 3, 4, and 5, 3, 4, and 5, a triangle can be formed in this instance. So I know according to my logic so far. Let's go one more time. 4, 4, 4. A triangle can be formed. So things look so far so good. Now I'm going to remove this. And in programming, sometimes you could just comment out code to remove it, because it could be useful in the future. Okay? So you comment out the code, and up to this point, let me comment on what we're doing so far. These are the lengths of the sides of the triangle. Ask the user for the side lengths or the values. If any one side is bigger than or equal to the sum of the other 2 sides, then print that the triangle cannot be made. Right? A triangle can be formed. So we could use this, what we formally created here, also as a bit of a comment. And we now want to say what type of triangle could be formed. So we go in and we have a nested if statement. So we have an if statement. We say if what? If, no quotes inside there. If side A is equal to side B, and side A is equal to side C. What does this mean? All right? What does this mean? If all sides are equal. All sides are equal. We want to printf equilateral. Else, if side A is unequal side B, and side A is equal to side C. Side B is equal to side C. If no sides are equal, printf else printf okay. So we print out the values based upon, right? Else in all other cases, two sides will be equal. Let's see if this works. We compile with 0 errors. And we say enter the 3 sides separated by commas. So let's go for a scaling. 5, 6, 7. Get scaling. Let's go for an equilateral. Right? 6, 6, 6. Equilateral. Let's go for an isosceles. And we have to check, let's say 2, 4. Sorry, not 4. 3, 2. Let's check with the values of 2, 4, 2. 2, 4, 2. Angle cannot be 4. All right, let's go 3, 4, 5, 5. Isosceles. So it seems to be working fine here. John Michael or Emmanuel, did you all see where you might have made an error as we typed it up? What was the error?
It was the and signs in front of the variables. I forget.
Okay. Okay. The ampersand here. These here?
Yes. Yeah.
That's what I asked you.
Sorry.
Yeah.
I didn't recognize how you had said.
Okay, no problem. Emmanuel, what about you?
Yes, I realize that you can't put a greater than sign in front of a equals, well, after equal sign, you had to pay before, so.
Yes, the format is greater than or equal to or less than or equal to. How are my other students doing? Let me just call a couple names. Brandon.
So here I'm compiling it and I'm having an error and I'm not sure why.
What is the compiler error saying?
Expected declaration or statement at end of input.
It sounds like you're missing a semicolon or a bracket somewhere. You want to share your screen?
All right, sir.
In the meantime, Hanson. Hanson? All right, Brandon, share the screen. Brandon, could you zoom in a bit? So click on your screen, hold down Control and scroll up. Right. Scroll up a little more now. Okay. All right. Yes, that's fine there. Okay. So you're missing a closing bracket after the else. So on line 17,
Yes,
if
sir.
you put a close bracket there.
I just saw.
All right. Carry it forward so that it's in line with the if and the else. Press tab, all right. Compile now and see if that Okay, unexpected statement before. No, a curly bracket, not a round bracket. Right.
I think so.
All right. So get in the habit of opening and closing your brackets together. Okay, so it'll spare you some pain. I'm not hearing anything from Hanson.
Well, so
Jeremy?
I'll go.
Yes, sir.
Never mind.
All right. Well, everybody spoke at the same. Hanson, how we doing?
I think I'm doing pretty well. Sorry, I stepped away to get something downstairs real quick.
Okay. Keon?
Yes, sir. So I just need to like remember to close my brackets, sir. But that it working now. But
okay,
I was thought in my head, I was like, where this bracket play? So I find all the brackets.
Yeah, so Jonathan says he has the same problem as me, which is why I put ISO. I couldn't remember how to spell these sillies. So, you know, that's for another programmer to hit the head up. Mahavir, Kishan.
Yes, sir, I'm here.
How we doing?
I'm following along pretty well.
All right, you got everything typed and working?
No, honestly, I did not, but I'm following.
Okay, all right. So you don't feel like you have a problem?
No, not necessarily. It's okay.
Oh. All right. What about Nissa? Nissa?
So I have to go over it one more time again. Some trouble with it, but yeah.
Okay, you trying to type it up, or are you getting any errors while trying to type it up, or no?
So I feel like I had to do over the whole thing, but I just had to. So let me start over from the starting, and I will do it all over again.
Okay, so you feel you need to just type it from scratch?
Yes, sir.
All right. Ola?
Yes, sir. I couldn't open. Well, I downloaded the compiler, but I can't open it because it will let my computer slow down. So after the meeting, I'll type it up and see.
All right, no problem. And Porter?
Yeah, everything done, yes, sir. It working good.
Okay, cool. All right, so we're in a good spot here. Okay, so we have a
The only thing that I find a bit confusing is the amounts of open curly brackets and closed curly brackets.
yeah, it could get a little troublesome, but normally you have the bracket highlighting like this, and you know, trust me, after a while you'll start to see the beauty of the brackets.
Yes,
So if you like this, but your screen not sharing, eh?
Oh, okay. I thought, right, I forgot that when the screen showed from somebody else, it took away from mine. Sorry about that. Okay. All right, so we have 10 minutes again. No, not 10 minutes, 20 minutes again. I just want to give a quick exercise. I'll put it up on the board on the screen for you to do. Just a quick program. It's not going to be anything difficult or anything so. And we'll just take it to the end of the class with that. So I wouldn't go into any sort of looping today, but on Thursday I would like to introduce looping, and that would be it. All right, from there we could start. I hope that we could touch on arrays before the end of the term and strings before the end of the term. Okay. right. Okay. I'm not going to do the 5 subject thing here. I'm just going to do input marks. So this is A mark, right, of A subject. And we want to print the grade. Or let me say, of mark, the input marks of 3 subjects. Of 3 subjects. From 0 to 100. And show the overall letter grade of the average. Right? Show the overall letter grade of the average of the subjects. Clear hint, declare floating point numbers using float or double. I think that this is something that we can do now. It's not going to take long as a little exercise. If you don't have your compiler open, you can write it out. I'm going to give 10 minutes to do it. 10 minutes to do it. And once it's finished, we will now. So we might just go a little past 11 o'clock. And that would be it for the class. So if underscore exercise. So this is to do now in class.
So you don't need a placeholder like how integer had percent sign D?
Sorry? Yes. Sorry, for float is percent sign F.
So you know how we did ing for integer? What is it for real?
Float or double?
Wait, what?
Float or double?
Okay, cool.
1% sign D. F. Right. So be clear. Let me put real numbers using float or double. Right. And if I put in the placeholders in brackets after them. Okay, so you declare it using float, double, and both of them use the percent sign F. I'll be right. Okay, so we're taking a look at what Porter sent. We have the include statements, it's fine. We have main, we have the 3 marks, we have the average, which should be mark 1, mark 2, mark 3 divided by 3. Enter 3 scores separated by commas. And we have the average is 0.1 F average, and then we have some statements in an if structure, if else if structure. We have it being entered. Okay, so we run it, and wow. Okay, it told me for a second there that my virus and threat protection came up. What did Porter send me?
No. It says clean.
All right.
It cleans it.
Well, Porter send me some suspect code here. All right, 3 scores separated by commas. So we have 17, 60, 45. We're getting the average to be a very large value.
Yes, see, that was the problem.
Right. Okay, so let's take a look at what happened here. You say float average is equal to Mark 1 plus Mark 2 plus Mark 3, but you did this before you actually had the 3 scores being entered. So we had a sequence issue here. This here can come after the statement because we need to have the values inside of Mark 1, Mark 2, and Mark 3 before we can calculate the average. Understood?
Yes, sir. Yeah. All right.
All right, so let's try it now again. So enter 3 scores separated by commas, 67, 45, 92. Average is 68.0. Let's see if these values. All right, let me try once again. But every time I run this is taking longer and longer. All right. 71, 71, 72. But you notice we have a little issue getting, we're not getting the floating point value to show. Okay, it is grade C, which is correct. It is grade C, which is correct.
So I think he had %D instead of %F when he was declaring his variables. I don't know if I see it correct.
Yeah, so I would have suggested, yeah, you're correct. I would have suggested to take in these grades as floats. Float Mark 1, Mark 2, Mark 3, and put this as %sign F, %sign F, and %sign F. So that way it does all of the operations necessary as floats. Okay. So let's try it again. 71, 71, 72. Now the average is 71.3. Okay, so good stuff. I would just take a look at the second one given here, which is what I'm seeing here from Keon. Anybody who did not work and they still sent it? So Keon had, let's see, he declared everything as float. What are the grades of the top 3 subjects separated by commas? So we store them in T1, T2, T3. We work the average. And okay, he went if average is greater than or equal to 90. If it's greater than or equal to 80 and less than 90. So this is good. So we got thrown off a little bit with our indentation here. We could fix that. And everything inside of main should have at least a basic indentation. I go crazy for indentation. All right, so forgive me. I'm very, very particular about how code is displayed. This is a little neater here.
So you come like a shine up, it's good.
If I come like, yeah, well, I think when it's in a certain format, it's just very easy to read. So I would rather spend the time to fix it up and make it, easy to read as it is here. I don't think anything is wrong with the code. Again, what are the grades of the 3 topics separated by commas? 72, 73, 73. This is a grade C. Okay, so the only thing that I would say that he didn't do was that he did not, as the question asked, he didn't declare, he didn't show the average of the subjects as well as the overall letter grade, which I asked to do, but that's fine. That's just a printf statement with a % F. Okay. I think that we can call it a class here today. I think it was important for us to just at least get the solution and the recording. You all did very well in terms of your solutions, and I think that we're heading in the right direction. Before we leave, anybody has any questions that they need to ask?
Yes, sir. So mine saying that I have no errors, right? But every time I run it and I put in values, it keep giving me, it keep printing the same thing saying the grade is F, like regardless of what values I put in. So I don't really know like what went wrong there.
You want to share your screen quickly?
Yes, sir. Right. So
You have a double equal sign on line 11 for average. Where it should be a single equal sign.
So I don't think you could use double here, sir. I think you have to use float if you're using %F now. I had the same problem when I changed it. See, I don't know, but
let's run it and see. Run it and see. Let me see.
So
press build and run. Let me see build and run.
Yeah, regardless of what grades up in, just keep saying the grade is F. So I don't even know what went on
All right,
there.
press. Average.
see, I had the exact same problem, and all I did to fix it was just put float instead of double.
It was put float instead of double.
Yes.
So close this. Yeah. Sorry, my bad. Float is put LF. No. Leave double. I just want to make sure that I could get to put LF for the placeholders. LF. Right. Try it there and see. Yeah. So a double is a long float. I apologize. So I will, before I upload the files that I would have had with it, I would put the LF. So double placeholder is LF, not just F.
All right, thanks, sir.
No problem at all.
So is it possible to get like a document with like the differences in symbols, like how for C you have to use the and sign and stuff?
Yeah, I will see if I could send something with a little bit of a primer. I'll send a note on it. Right, just send me a message in WhatsApp and I'll send a note.
So I don't know if I trust you on that WhatsApp thing, you know. Like last night,
what you mean, boy?
You leave me blank, you know. So you leave me blank.
With
I
what?
asked you if you're having class Tuesday at I can't remember the time, but it was like something 35, and then at that something 38, you post that it's not having class. So
How was
No, but I didn't even watch WhatsApp. I posted
Well, you see,
that
and you want me
it
to
not,
message you on WhatsApp, and you're not
yeah,
gonna
but
watch.
all right. Think about it like this. I would have finished the supplementary session probably about 10 minutes before that. So I didn't know that you messaged me. I just say, okay, well, let me update Teams with the message that say, well, we're not having classes physically this week. That was
And
pure coincidence.
you give me a set of disappointment because I wanted an excuse to leave the people's house. All right, we won't complain. I'll message you later just to
We'll
remind you.
see what we can do for next week. Thank you very
Yes,
much, Omar. All right, so that's it for me and you guys today. If there are no more questions, any more questions?
No, sir.
Yes, sir. Yes, sir.
All right.